Thanks for coming. My name is Maarten Dirkse. I'm going to be talking about a service we wrote in-house to manage Spinnaker called Jumper. So let's get started. That's what I'm talking about today. First I'll tell you a little bit about Bol.com, my employer, and myself. Then I'll tell you a bit about how we got to be using Spinnaker and the Kubernetes setup that we have, and then why we needed Jumper. And then we'll have a short demo, and I'll tell you a bit about next steps and some findings that we had while running it. So let's get started about my company. Bol.com is more or less the Dutch Amazon without the AWS part. We're the largest online retailer in the Netherlands and the Dutch-speaking part of Belgium. We have 8 million customers and close to 18 million products and counting. And our IT organization is 400 plus engineers, 350 plus applications, and about 60 Scrum teams. Fun fact: when the IT organization now, as a part of the company as a whole, is just as big as the company in its entirety was when I joined 6 years ago. So we're growing pretty fast. And about me, you can find me on Twitter. I work at Bol as a cloud advocate. That means I make people inside the company enthusiastic about our transition to the Google Cloud, and I make people outside the company enthusiastic about what we're doing during that transition. I started out as a Java developer, spent a fair few years working on the CI/CD team inside the company. So I have a special fondness for CI/CD and for containers. And finally, I'm a football enthusiast, and the real football, in case any Americans here were wondering which one I was talking about. So I had to get that dig in. So how did we get to use Spinnaker? Well, it all started during MesosCon in 2016 in Amsterdam, of all places, where I attended a talk called The Evolution of Deploy Tooling at Twitter by a Twitter engineer called David McLaughlin. It was a really interesting talk. He spoke about internal tooling that they were using to do all kinds of different deployment techniques, and it just sounded great. So at the end of the talk, I was pretty excited, and so were a lot of other people in the room. And someone raised their hand and asked, "Well, David, that sounds awesome. When are you going to open source this tool?" And he said, "Well, we won't for various reasons. But if you want to have access to something that does more or less the same thing right now, there is a tool called Spinnaker out there which you can use." So I thought, great, we can start using Spinnaker. But at the time we were running, and we still are to a large degree, running in our own data center. We have most of our apps run on VMware virtual machines, a platform which is not really targeted by Spinnaker. So at the time it wasn't really an option to start using it. So the stack, so I call this the current stack. The current stack in our data centers, we have Jenkins that does the builds, Artifactory that stores the artifacts, and then we have Rundeck and Puppet, which actually are responsible for getting those artifacts out to the virtual machines and making sure that the software runs as it should. And then during the summer of 2017, so last year, we decided as a company that we were going to move to the cloud, to the Google Cloud to be precise. And so this gave us an opportunity to kind of reevaluate the stack and see if we could do better in the sort of cloud native world that we are going to. So there's a bunch of drawbacks with this. Jenkins had become a maintenance nightmare for us. We really didn't want to be running it anymore. We wanted to move to something like the Travis CI model, where users just organize their CI themselves and don't really come bother the team that's running the tool, because they can do everything by themselves. Artifactory, we knew we were going to go to the cloud and base everything on GKE, on Kubernetes. Artifactory isn't really a great Docker registry. I mean, it works as a Docker registry, but you have to arrange your own storage, and there's not all these fancy integrations that you get with other Docker registries like GCR. We used Rundeck to do orchestration of RPM builds. Rundeck is not a deployment tool. Rundeck is more or less a distributed script runner. So that wasn't ideal either. And then finally, we used Puppet to actually roll out the stuff on the VMs. And obviously, that is not immutable infrastructure, and immutable infrastructure was something that we wanted. So the team that I was on, the CI/CD team, set about sort of figuring out what the new stack should be. And this is what we settled on. We use GitLab CI to build software and build Docker images. And the nice thing about GitLab CI is that it's completely self-service in terms of what users can do in their pipelines. So more developer control and less DPI maintenance. DPI is the team that maintains the CI/CD infrastructure. Then we use Google Container Registry to actually store the Docker images. And so that's really great because Google handles all of that. We don't need to worry about any of that. We don't need to worry about, like, is our storage full because we're storing too many Docker images? Is it up? That sort of thing. It's all Google's concern. And then we use Spinnaker, which we could finally use because we were moving to Kubernetes to GKE. And Spinnaker, as you know, is an actual deployment tool as opposed to Jenkins, as opposed to Rundeck, as opposed to whatever else you might name. So that's really nice to use an actual deployment tool to do your deployments. And then finally, Kubernetes, if the way it runs stuff facilitates immutable infrastructure, which was really great as well. So that allowed us to dive into Spinnaker, but we had a kind of quirk in the way. Well, quirk. We had our own ideas about how we wanted to set up Kubernetes, how we wanted to set up GKE. And that is what I call service compartmentalization. I should have practiced it a few times before the presentation, probably. Or I shouldn't just make up terms. So service compartmentalization, I'm going to get that right sometime in the next half hour. Essentially, what we wanted to do is make sure that every service runs in its own namespace in Kubernetes. And we want to do this because it facilitates isolation, it facilitates all kinds of benefits that you get from making sure that services can't step on each other's toes because of the namespace limits that you impose. And it also facilitates a security model whereby teams can deploy to the namespaces of the apps that they own, but they can't deploy to namespaces of other apps. And so this is in contrast to what you often hear about as a model where you have a GKE instance or a Kubernetes instance where you have one big namespace for production, for instance, or one big namespace for a team or other kinds of cross-cutting ways to manage your namespaces, which aren't down to the service level. So we wanted to really isolate everything to make sure that if anything goes wrong, the blast radius is really limited. And if any accounts are compromised, then you can only access the one namespace, et cetera, et cetera. So we wanted to chop up our Kubernetes namespace according to services. So the way we do this is we have a homegrown management tool, which is a layer across basically Puppet and Terraform, which actually goes out and provisions stuff for us. And in this case, GKE or Kubernetes namespaces within GKE. We have different Kubernetes clusters for staging and production. So every application has a namespace inside the staging and the production cluster. We didn't want to use any God mode accounts. So we didn't want to have all these namespaces, but then still have these service accounts that can basically deploy anywhere. We wanted to keep that restricted as well to the services. And so we have the namespace and the GCR repo, which is also relevant for the Spinnaker use case, per application, per cluster. So like I said, isolation, resource management, billing, limited blast radius, all this stuff is facilitated by the fact that we chop it up by service. And the other important point is that everything should be self-service. So we like to joke on the CI/CD team that we really don't want to talk to our users. And if we're doing our job right, then we don't have to. Because they can arrange for everything themselves and they don't need us to do anything for them. That's the ideal situation. So teams should be able to do everything themselves. They shouldn't need to come to us to create some config or something to be able to deploy to Kubernetes with Spinnaker. So the setup that we have of Kubernetes means that a team can create a new application using our homegrown provisioning tool, which will then go out and create a namespace. And then you want to be able to deploy to that namespace using Spinnaker. So how do you configure access to namespaces in Spinnaker? Well, you configure a Kubernetes account. You have to configure a set of credentials, not only for the namespace, the cluster and the namespace, but also for the GCR repository in which the Docker containers live. So how do you do that? Well, the usual way to do that is to configure it in Halyard. But we didn't really want to do that. We didn't want to have to run Halyard every time by hand that a user created a new namespace, because that wouldn't scale. So at first we thought, well, we can just go to gate, and there must be some sort of post command for the credentials, and there isn't. And for those of you thinking there might be on the actual Cloud Driver service, there isn't either. We went on Slack and we asked, can we do this using the API? And the answer was basically no. And making that possible, so creating a patch that would make that possible to do by API would basically entail rewriting the whole of Cloud Driver in some way. So that wasn't really feasible either. So that wasn't going to work. And then we figured, well, you can use Halyard to add those accounts, and Halyard actually knows how to do seamless redeployments of Cloud Driver, because Halyard uses a kind of special version of Spinnaker that it deploys, and then what's called the bootstrap version of Spinnaker, and then it uses that Spinnaker to deploy the actual Spinnaker using the usual sort of zero downtime techniques that Spinnaker enables. So we thought, well, Halyard can do this for us, but we really don't want to be issuing those Halyard commands all the time by hand. We want to automate that some way. And also, the way that Halyard is usually run, at least at the time we were trying to figure this out, we actually went on Slack again and asked, so how do people usually run Halyard? And the answer was, well, they spin up a VM in whatever cloud provider that they use, and then Halyard runs there, and then actually provisions into Kubernetes or provisions into AWS or whatever. That wasn't ideal either, because from the very beginning of our whole cloud migration, we had decided that we wanted to run everything as containers. So the provisioning guys, they would repeat this mantra, everything must run in a container. And then we said, well, we got this tool called Halyard, and usually people deploy it on a VM, and then they run it from there, and then they were like, everything must run as a container. So we said, fine, we'll try to figure out if we can run it as a container. And then at the same time, we wanted to instrument it so that we could actually we could automate Halyard to deploy these accounts in some way, so that we didn't have to babysit the tool, and that teams crucially wouldn't be dependent on us doing some manual action before they could use Spinnaker. So we created a service called Jumper, and as you might expect, Jumper has a nice sailing-themed definition. So sweating the Halyard. Jumping the Halyard is a technique used to raise a large sail quickly by employing a few crew members to work simultaneously on the Halyard. As you may or may not know, Halyard is a rope used to raise a sail, and Spinnaker is a kind of sail, so it all works quite nicely. So we called the service Jumper because that's what it does. It uses Halyard to quickly set up stuff in Spinnaker. So how does it work? Right. So let me walk you through this diagram. So we have R2D2, which is our internal provisioning tool that runs based on YAML files. So if you want to change something about if you want to create a project or change something about your project infrastructure, you feed your project YAML to R2D2, and it then runs, creates all the infrastructure you need, like your Kubernetes namespace, buckets, whatever. But what it also does is it takes the service accounts which give access to the namespace and access to the Google the container registry, and puts them in a config map in Kubernetes. And then we have Jumper, which periodically scans these config maps for the entire cluster, pulls them all in, and uses those credentials to write out a Halyard config file. So we skip the CLI. We don't actually use the CLI to build the config file. We just use a template and build it directly. And then when the config file is built, we then use the CLI to kick off the Halyard daemon, which then takes the config file and uses it to deploy Spinnaker. So the steps are: the R2D2 tool uploads the credentials, Jumper ingests those credentials from the cluster, and then feeds them to Halyard, essentially, and Halyard then goes out and configures Spinnaker with the accounts. Does that make sense? All right. So the implementation, how did we go about actually doing this? Well, the first thing we learned quite quickly is that you only want to be redeploying a very small part of Spinnaker, and namely only Cloud Driver, because if you redeploy the whole thing, it can easily take up to 20 minutes, and having to wait 20 minutes before your account appears and before you can actually deploy stuff is not a great user experience for teams that want to get set up and running quickly with deploying new applications. So you can actually tell Halyard to only redeploy a very small part of Spinnaker, Cloud Driver, and that speeds up the process a lot. 20 minutes down to 3 or 4 minutes, something like that. But you still want to enable a full redeploy if you for whatever reason, want to change some configuration that is not account related. So what Jumper also does is it has these config maps for all the different account credentials, but it also has a configuration map for the more general settings in Spinnaker, like what the URL of gate is, what the URL of the front end should be, all these general settings that have nothing to do with the account specifics. There's a configuration map for that as well. If we update that, we want to be able to do a full redeploy so that those settings are propagated to whatever services need them. So we have a switch in Jumper that says, force a full redeploy. Just go out and get all the configuration and redeploy every single Spinnaker service that's out there. Like I said, we didn't use the CLI. We could have written Jumper in a way that for every single account it went out and did this, Halyard add account actual CLI command, but those tend to take quite a long time. And if you want to do 65 of them, or in the future 100 something of them, and then for 2 environments, that would have added many minutes to the total runtime of generating the config, so we didn't do that. But then the problem is the Halyard config file has no defined spec, at least none that we know of. It's kind of an implementation detail of Halyard, so we have to kind of keep up with what the latest config file looks like in new versions of Spinnaker, and make sure that we adhere to that standard, in as far as you can call it a standard, so that Halyard can still understand what we're feeding it. We get the account configuration from encrypted configuration maps. So what the deployment tool uses a public key to encrypt the information and stick it into a configuration map, and then Jumper has the private key which can then de-encrypt. So that's not really ideal. At first we thought, well, we're going to use Kubernetes secrets because that sounds like that's what they're for, using them for secrets. And then it turned out that you actually can't go out and scrape all the secrets from a cluster, or at least when we first built the service, that wasn't something that Kubernetes supported. Whereas you can do that with configuration maps. So you can't go out and say, give me all the secrets that have label Jumper, for instance, but you can do that with configuration maps. So that was the reason we went for configuration maps. As soon as we did that, we knew we had to encrypt the information somehow so that it wasn't sort of readily available to anybody with access to the cluster. In the initial version, we did polling on a kind of 3-4 minute basis, if I'm not mistaken. But you don't want to be redeploying when you don't have to. So you want a mechanism, or we built in a mechanism that actually does a checksum of the template and then figures out whether or not things have actually changed. And to add to the polling, we also listen to config map change events. So we hook into Kubernetes and listen to these events that come in when something actually changes in the config map. And then when we do that, we go out and we scrape the entire cluster and rebuild the config file. A couple of findings that we had while running this stuff. So first of all, as Remco said, the Cloud Driver redeploy duration can be really, really unpredictable. And it's kind of hard to get a handle on that because it's all sort of tucked away in the Bootstrap Orca and the Bootstrap Cloud Driver that actually do the redeploy of the real Cloud Driver, so to speak. And it can take 10 minutes, it can take 3 minutes, it can take 2 minutes. And there's really no telling how long it'll take when you run it beforehand. And it's really hard to get a handle on why there's such a huge variation in how long it takes. So sometimes, the cache updates will take longer. Sometimes, sometimes deploying will take longer. Sometimes startup times will be longer. And it's really, really difficult to figure out exactly why that is. Keeping up to date with the Halyard config file format is a challenge. So essentially, because it's not specified anywhere, or at least not that we know of, besides the code, you kind of have to go out and when there's a new version of Halyard, just sort of run some commands that you know you'll be needing, and then look at the output and then update your template to match the output. Yeah, so Remco showed you the HipChat notification. Users really want to know that their problem is being worked on, so to speak, so they can go to the channel and see, like, okay, we're redeploying Spinnaker, so I just I just created a new account, or I created a new application, and the redeploy happened after that, so I know that my account will be available when the redeploy is finished. Otherwise, they're kind of in the dark, and they're constantly sort of pressing F5 on Spinnaker and wondering why they can't see their application. And so checking if the config actually changed can be a little bit tricky. So what we do, which is kind of the bare minimum, is to look at the actual file that we produce and then compare that to the last version that we produced. And if there's any changes, then we know that we need to redeploy the config. But because the Halyard file contains all sorts of references to the credential files themselves, so the Halyard file essentially has a file path to the credential files that you need. It doesn't actually contain the credentials. So ideally you would go out and check all those files as well to see if any of the credentials have changed, because that can happen. So service accounts can sort of update their credentials, and if that happens, then the actual Halyard file won't change, but your configuration will have changed and something will break if you don't redeploy. So that's we're trying to figure out exactly sort of how to do that. But there are some things that we still want to do. Notably, artifact accounts. So artifacts are becoming a pretty big feature of Spinnaker. We want to enable the whole Kubernetes v2 artifact workflow, including the Helm stuff as well. And for that, you need artifact accounts. Artifact accounts are in no way secured. So they aren't coupled to fiat, so anybody can use them, which means that we will have to create, for example, GCS buckets per application in which people can store their artifacts, so that they can't be overwritten by other teams. And we need to work that into Jumper as well, so that those artifact accounts are automatically configured and people can use them without having to do any extra work. And what I personally would really like to do, but I have to discuss this with the team that actually runs the service, is to open source this, because it might be useful to other people as well.